Everybody, just wanted to see if anyone had done the challenge problem. So remember the challenge problem said that given that negative 3 is a 0 of this polynomial, p of x, I want you to factor it completely. So if you haven't tried this, but you've stumbled across this video, if you want to pause the video right now and give it a shot. So we know negative 3 is a 0, and what I want to do is be able to factor this into its three factors. So if you want to give that a shot, you can pause the video now, or if you want to keep watching, I'm going to go over the solution right now. So if negative 3 is a 0 of p of x, then x plus 3 must be one of the factors. We know x plus 3 is one of the factors. So what that means is that p of x is going to be equal to x plus 3 times two other factors. So it's going to be x plus 3 times some quadratic over here. If we can figure out what that quadratic is, then we should be able to factor it. So since we know that x plus 3 goes evenly into p of x, because it's a factor, just like, like 3 is a factor of 12, right? 12 equals 3 times 4. Then we should be able to divide p of x by 3. So p of x should be, sorry, x minus plus 3. We should be able to divide p of x by x plus 3. That was a terrible little addition sign there. So p of x, we should be able to divide by x plus 3, and that's going to give us some polynomial. We'll just be left with whatever these two factors multiply to be. We'll call it q of x. So we should be able to divide, and there are two ways that we know to divide now. You could do it with long division, so if you'd like to do it with long division, you can. But what I'm going to do is actually just do synthetic division. So remember, that means that negative 3 is going to go into the box. And we should end up with a remainder of 0, because we know that it's a 0, so it's a factor. X plus 3 is a factor, so we should end up with 0 for our remainder. So now I'm going to list out the coefficients of p of x, which are 1, negative 3, negative 10, and 24. And draw a line down here. The 1 comes down, multiplied by negative 3 is negative 3. Add those, we get negative 6. Negative 6 times negative 3 is positive 18. 18 minus 10 is 8. Times negative 3 is negative 24, and good thing we get that 0 remainder. So that means that the result of this division is x squared minus 6x plus 8. Remember, these are just the coefficients of our result. So right now what I know is that p of x is equal to x plus 3 times x squared minus 6x plus 8. So I've been able to divide and show that it's x plus 3 multiplied by this other factor, x squared minus 6x plus 8. So I'm going to take this guy right here and go to our next slide just so we have a little bit more room. So x plus 3, and then we have x squared minus 6x plus 8. I'm going to write that down. X squared minus 6x plus 8 times x plus 3. That's what we know so far of p of x. But the problem says to factor it completely. We want to factor it completely, so we have to factor this quadratic as well. Well, we can do that with an x box. 8 times 1 is 8. B goes in the bottom, negative 6. So we need two things that multiply to 8 but add to negative 6. Well, I think negative 4 and negative 2 will do the trick there, because they multiply to 8 and they add to negative 6. So I'm going to make our box like that. So in the top corner we put just x squared. Bottom corner we put 8. Then we have negative 2x, and we have negative 4x. Common factor here looks like it's 4. Common factor here looks like it is just x. And then common factor here is 2. Common factor here is x as well. Now we have to double check that it works. So x squared, well, we should get a negative 4x here, and we should get a negative 2x here. So those are probably going to both have to be negative. And now we get positive 8, and we get the negative 4x and the negative 2x, so it all works out. So this factors into be x minus 4 and x minus 2. And then we know we have x plus 3 is our initial factor. So that's the complete factorization of p of x. So that's kind of cool, because just given 1, 0, we were able to factor it all the way out. So I hope that you were able to get this solution, and I look forward to seeing you guys tomorrow and doing some more of these problems. Talk to you soon.